Sweet. So now that we're recording, I guess this is start of the club meeting. We'll be going over some macOS malware, specifically if you've seen in the news, it's called Silver Sparrow, and we'll also be talking about a blog post from Objective C by Patrick Wardle, and that'll sort of be the topic for today. But then we also have some opportunities that Josh, who's one of the graduate professors at DSU, would like to talk about. So I can just kind of hand it off to Josh if you'd like to.
Sure.
And so however much you have to do and go over, Josh, like if you have like a whole half hour or whatever, feel free to use it however you like.
Do you guys post these videos anywhere?
Yeah, on YouTube.
On YouTube? Are they public or private?
It's public.
Public, okay.
If you want, we could not acknowledge your name in it.
No, I don't mind. I was just curious since I saw you started the recording. I was just curious where you put them. Yes, okay, well, thanks. I won't take too much time here. So thanks for the brief intro. I don't think I know some of the names I recognize, many of them I don't though. So I'm Josh Stroschein. I've been at DSU for, this is my 7th or 8th year. I've kind of lost track, 2013. So this will be my 8th year. Started as an instructor teaching fun things like 150 and 250 and have kind of moved through all the different academic ranks. Right now, I'm mainly teaching the graduate programs, which is why many, and at least in the undergraduate, probably haven't heard of me, or at least certainly haven't taken a class with me. Outside of DSU, I work for OISF, which is the nonprofit that supports the Suricata project. Suricata, if you're not familiar, is open source IDS, IPS, MSM. I still do some work for Bromium, which got acquired by HP last year, do threat research with them, and have been with them for about 4 years now. I do cyber with the Guard and have been in the Guard for 20 years in June. I author on Pluralsight, do some trainings at conferences, and you can generally find me sticking my fingers into all things cyber that I can get them into. So if you see me somewhere, please definitely say hi. I don't know if you guys had any, we didn't really get much of a chance. We came to the idea here that I would join the meeting last week. So I didn't really have a lot of time to think through a good topic for tonight. I ended up being at drill this weekend, last 4 days, so it just consumed all of my thought cycles. Part of what I guess brought the invitation about was that I been talking to Micah and Odin about doing some mentoring. I have a couple of other students that have reached out to me, and I've been working with them one-on-one to do a variety of different tasks and helping them in their transition from really, finishing their degrees and getting into a role that they want, particularly with malware analysis. But certainly I could be more helpful beyond just that. So if that's anything that anyone's interested in, I'm not expecting to get a large group, but I have, two students right now, and I'd be more than willing to and happy to have a few more join in. Not 100% sure where the direction is going to go on that, but right now we're just starting to meet on a regular basis, and I'm more or less giving them, tasks and other things to work on that I know will help sharpen their skills and broaden their experience. Where we take that work, I'm actually in the process of getting a blog set up under DSU proper. I think that would be a great place to publish some work. I've also got some contacts at places like Inquest Labs, AnyRun, Bromium, HP themselves. All of these places are looking for guest bloggers. So I think that would be another good opportunity after we get some work established, to maybe pursue one of those outlets and see if we can't put these publications there. And then there's just any number of, I'm sure much like all of you, any number of projects and things that I would love to have some help working on. So definitely can do that. Odin's worked with me the last year on an NSA grant, and he can fill you in if you want to bother him with, okay, I see the link, what it's like, what some of the things that we've been working on. So Odin, if you can hear me, please feel free to share that if anybody reaches out, just the high level details anyway. Outside of that, we could certainly talk through some malware things. I think that would be one of the areas I would be the most interested in and helping out on the Malware Club. So is there anything in particular anyone wants to talk about? I might be able to do a few things just off the cuff. Otherwise, I have some ideas just to spend a few minutes talking through a sample that I've been looking at recently. Typical cyber thing. Everybody's got their video off, but Micah, you probably feel obligated because you're the.
Yeah, I'm trying to be more sociable.
Yeah.
Had it off the past couple times we met.
Yeah, I did a training a few weeks ago, and everybody's was off too, and I started giving them grief, and they said, well, but every one of them said they had a docked laptop so they didn't have a webcam plugged into it. I said, yeah, right, likely story. Okay, well, like I said, I've got lots of ideas, lots of things we could discuss. If anything comes to mind, certainly, let me know. I'd be more than happy to come back and talk about things that I can talk about. One of the things I thought we could just jump into real quick, I come across JavaScript quite a bit when it comes to malware, and not JavaScript in the sense that it's used in the browser, but JavaScript that's used by intended to be executed by the operating system, by Windows in particular. So C script or W script, pretty common, or probably one of the more prevalent downloaders out there is OSTAP, O-S-T-A-P. And if you haven't looked at OSTAP, I would challenge you to go grab a sample of it and take a crack at deobfuscating that. It's got some pretty heavy duty obfuscation, a little bit of anti-analysis. And it's the typical use for OSTAP as a downloader then is it's either embedded or it's retrieved from a malicious Office doc, and it's executed, dropped and executed, and then that's what downloads the next stage. So that's a pretty common use case that I run across, that JavaScript. Post-infection tends to be, more of the living off the land stuff that you might expect, the PowerShell, and then just other executables. I want to share my screen if I can. You might have to make me nope, looks like I'm good to go. All right. Can you see this okay?
Yeah.
Okay. And stop me if you lose interest, because again, I just thought this would be something fun to talk about. This is actually one I've used in classes for a while, and I'm at the point where I'm probably going to retire it, but that doesn't mean, just because it's old doesn't mean it doesn't have a lot of interesting things to discuss in it. I forget what this actually even was intending to drop. It's been long enough, but a couple of years, it's a couple of years old. So I don't even remember, but it's sort of a downloader. It's got a little more functionality in it probably than a typical downloader. So there's some stuff in there to play with. But it's JavaScript, as you can see here. The first thing that you likely want to do with JavaScript like this is unravel it. And we can see that this is likely, this code that we're looking at right now is likely all responsible for unpacking or deobfuscation, because we have this big blob of text down below. So likely this is our next stage. So this is the thing that we're actually looking at seeing if we wanted to analyze this further. Why might we care? Well, let's say there's some anti-analysis in it. OSTAP, for example, it does a couple of different things for anti-analysis. One of the last samples that I looked at, what it would do is it would enumerate all the processes on the system. It would put them into one string. And then if the string wasn't long enough, then it would assume that it was in a sandbox or some analysis VM, and that would stop it from doing anything further. It would just error out. So things like that we might have to dig into to understand and improve our tools, improve our environments. Micah, what do you think this string looks like? Can you recognize an encoding or a format that you would maybe use to take next steps?
Yeah.
Is it okay to like call everybody out by name since you're making these public?
I would think so.
I mean, it's your name now, so I guess if you don't want it out there, you'll have to go back and edit this.
Make bleeps over everything.
Make it bleep redacted, and then you'll have to blur your face as well.
Mm-hmm. Put bars over everybody's eyes. I would guess like base64, or maybe there's a function that decodes it with a key.
Okay, yeah, so definitely base64, and usually the tells with that, we've got this little equal sign here. So the encoding is block encoding, and when the string or the data that's encoding doesn't fill all the blocks, it just pads it with an equal sign or two equal signs. So that's one indication. The character set, alphanumerics with a couple of special chars, that's also a pretty good indication. That and then it's just tremendously popular to base64 things as a way to make sure that the encoding, can make it across networks and other ways, especially if you're dealing with lower level binary content, maybe shellcode or something that was inside there. Let's see, what could we, so yeah, definitely base64. If you just look at these two functions, does anything jump out to anyone? I mean, obviously they're a part of unraveling whatever this is, but does anything strike anyone as obvious or apparent as to what the purpose of either of these functions are?
If anyone doesn't want to talk, you can use the
chat
box too.
Yeah, absolutely. I got to open the chat though. Okay, so it's sometime, yeah, pulling chars from the array, definitely they're going to be used to manipulate this content. No doubt about that. You see things like from char code down below here. You see things like char at here, and likely, yeah, it's going to go through the characters. With these two functions, this first one, LXV5, which is a form of a Corvette, one of the bigger indicators here that you're dealing with base64 would be this string, and that this is actually an implementation of base64 encoding and decoding in this case, because it has that default char set, and you'll see that this oftentimes in any malware that's going to implement its own. I say custom, and I only mean that in the sense that it's not importing it from a library. PowerShell, we could use the from base64 to base64. It's part of the environment. It's just available. But you could also implement it on your own, and in which case then it would maybe a little less obvious because you don't have a function that says from base64. Although anybody with experience will recognize this character set, maybe the equal sign, and then this string helps you to recognize that function. This one, not quite so clear what this one is, at least not by looking at it. Of course, the obfuscation that you can see in this sample is just, there's no formatting or very little formatting. The variable names are nonsensical, function names are nonsensical. But other than that, it's actually pretty straightforward. For example, if you looked at this implementation of the base64 decoding with a proper, well-formatted, or even if you formatted it yourself, you'd see that it's pretty good. They just obfuscated the variable names. What they could have done to make it more difficult was they could have broken up the string. They could have added more unnecessary code, things to make it harder to recognize. If we go back up to the top though, this is where this whole thing starts to unravel. Key indicators, or when it comes to working with obfuscation, one of the things that I always look for, especially if I don't want to hassle with figuring out what all of that other stuff does, is just where the code will be deobfuscated. When you see this beginning of this JavaScript file, you know that it's going to just start execution from the top because there's nothing else here. All the functions are defined below. And so there's a call to eval, and this is a pretty common enough that you see, particularly with interpreted languages, and that the eval is just being used to execute some code. That doesn't mean that the next stage isn't obfuscated, but we know for sure that it's going to be valid JavaScript. So a couple things happen. This first var es3c calls this function, and that's just simply returning that long string that you see down here. The next one calls LXV5, which makes sense. That's our base64 decoding. So it's this one right here. And then we have this last function called CPPT, which is the one that we were just looking at, but we didn't spend any time analyzing. And that takes not only this variable that contains first the string, then the base64 decoded string, but also this variable SSWZ. So where does that come from? That comes from right here. And Mike, I think you mentioned earlier that maybe this is something that requires a key, and it does, or it requires some additional form of input. And we know that because of this environment variable thing not environment variable, but this object and this property, so wscript.arguments is going to get the command line arguments, and then we're going to get the first argument. So unlike argv that you might be used to with like C, it doesn't include the name of the program. So the first argument from here is just literally the first argument, not the name of the program. So it does need one input value in order to do whatever it is that it's doing. If I gave you this file and I didn't give you the key, where might you find it? Does anyone have any ideas on that? Thoughts?
Twitter.
Twitter, yeah. Twitter is a good place to look. If you just search on Twitter right now for maintools.js, you'll find it. There's a couple of threads out there that have the key. Let's say that Twitter wasn't there. It wasn't on Twitter. Where else might you go? Well, if it requires an argument, what does that tell us about how it was executed?
Executed on the command line.
Okay. How did the argument get provided then?
The malicious actor maybe included it in an email or something.
Yeah. So if this is dropped from an Office doc, then the macros in the Office doc just had the argument, the key, when it executed this via whatever it did. Probably a shell, an instance of a shell object in the macro code. Which means that if we wanted to find the key, and it wasn't on Twitter, it is on Twitter, but if it wasn't on Twitter, then we'd have to find, hopefully, what was responsible for delivering it. And we won't have time to go through that, otherwise I'll get really long. But one way that I found this is just to look at some of these strings inside of this document, assuming that this function name and some of the different variables in here and some of the different statements are going to be unique. You can actually use those to find results on hybrid analysis. Had this document originally. So it had the document, you could look at the process tree and you could see, word spawn cscript.exe with the name of the JavaScript file maintools.js and then the actual key. So sometimes you have to get creative, and there are a lot of really great resources out there for doing threat research if you're not using them already. You don't have to pay for everything. We do need the key, so I'm going to go grab that real quick. Oh, how do you search on Twitter? Stupid thing. Does anybody know? I always forget. Okay, I'll just do it from my host.
You could just do like a Google site search for Twitter. It's probably not the exact same thing you're trying to do, but
no, yeah, I know what you're saying. It's okay, I got it. I'll have it here in just a second. Since I can copy and paste, you just won't see it. So if you search for maintools.js on Twitter, you'll see the threads I was talking about. Okay, so how might we get this code out? Well, one thing we can do, this is an easy approach that isn't always effective, but I call this the lazy person's function hooking. In languages like JavaScript, oftentimes we can just define a new function. Let's do wscript.echo so that we can get the content that we want to see that we suspect is going to be deobfuscated. We can dump it to the terminal, which means that we can redirect it to a file. And then you can reassign eval to our new eval. And that works. So that's redefining the function pointer. Of course, in other languages, lower level or mid-level kind of languages, non-interpreted, it's a little bit harder to hook functions, but certainly it can be done. This is one way to do it. One thing to keep in mind is that eval is no longer going to call eval. It's going to call this new eval, and all that's going to do is echo whatever argument was there. So some scripts that have more of a dependency on eval, maybe multiple calls, maybe some nesting or something like that, that could break it. In which case then you can do something like this. Grab a pointer, and then you can then call the old eval if you want to inside of your newly defined one. So just something to keep in mind. In this case, The other benefit that this serves is that it more or less neuters the malware. So if we're not executing the next stage, then we don't have to worry about infecting the system. This is not destructive malware. It's not like ransomware or something where you might actually have to reset your snapshot, but it is just something to keep in mind. We can now copy this or save this and go to a command prompt. This evil command prompt. Okay, can you see that okay, Micah?
Yeah, looks good for me.
Looks good, okay. And let's do cscript.exe and maintools.js. Okay, so we ran it, we got nothing. We should have seen some output. We'll give it an argument. We run it again. Now we've got some output, but it's gibberish. So we'll clear that one last time. And now we'll grab the key that we found. Paste that in. There's the key. Micah linked to the Twitter in the chat. And now we see we got the next stage script. So looking much better. We can now redirect that. I'll just call this stage2.js or .bin in case you're worried about accidentally executing it. And now we can open that file. Oh, I don't like that. All right, now I've got a dialog box somewhere. I don't know where that is. Oh, it's right here. There we go. We got all the outputs. We want to get rid of that leading trademarking nonsense from Microsoft, and then there it is. My internet connection's unstable. Can you guys still hear me okay?
Yeah.
Okay. There we go. We'll just give it some syntax highlighting. So in this case, quite a bit more functionality. We can see some of the probably more interesting bits, especially if we're just doing some quick analysis. These IOCs, these domains that it's reaching out to, whether that's for check-in, command and control, or maybe another payload's coming. I don't know. I've never really looked at this one in too much detail. I've always just focused on unraveling this first stage to talk about some of the basics of deobfuscation. It certainly looks like there's quite a bit more in terms of just the commands based off of the strings. So, you know, the value to every threat actor or every pen tester in hiding this information is that when your tools get looked at, which I suppose in a pen test scenario, you're probably not as worried about your tools being, you know, investigated and studied after the fact. You're just worried about them being effective and getting you in. Still, it's the kind of stuff that you want to leave behind. We can see this character set, so it looks like they've implemented base 64 here. And then one other item that I just want to touch on was just, if we go back to the original, this function here, so this CPPT, which we didn't really talk about yet, but we now know that it is the last function that is called. So it's responsible for decoding or further decrypting, in this case, the contents from base 64, and it requires that key or that argument. Beautifier.js. Yeah, there we go. So I'll just paste this in and we'll format it, copy it. We'll go back to our text editor, paste that in. Okay, now that we've got a little bit of structure, does that look familiar to anyone? And I'm not saying it should. I'm just curious if it is or if it does. Okay, while you're looking at that, I'm gonna get another thing pulled up, so just give me a second. Bramwell, does it look familiar to you?
Looks like it's cycling through, it's doing a block cipher methodology. Because it's got a 256-bit, 256 integer 256, so it looks like it could be like doing like some sort of 256-bit encryption. Well, byte.
Yeah, absolutely. It's RC4, and so this is just an implementation of RC4. And if you look at it, I was going to try to find a sample of it, just a straightforward implementation that somebody wrote in JavaScript that has proper variable names and everything. But if you did that, you'd see that definitely it matches up. It's pretty much an exact implementation, no further obfuscation. I forget all the bits here, but this is your S box, and then this is your random number generator or something, and then there's the decryption part. I didn't bother to refresh myself on how exactly RC4 works, but in recognizing that, it at least negates us having to go through this whole process of trying to unravel this dynamically, which we did. So the benefit, of course, to doing something like this is that we didn't have to worry about all of the implementation details. We just figured out where the next stage is deobfuscated, and we extracted that, and that's happy with that. We can move on. But again, if we want to get a little bit deeper, certainly when you start encountering more complex malware samples, the Trojans themselves, typically you see implementations like this, and it's much more important because it's a bigger part of their functionality in understanding how they're encrypting parts. RC4 symmetric key, it's lightweight. It could be as simple as using it to encrypt strings inside of the binary, in which case then you could write some IDA-Python or a Ghidra script to go through, and once you've recovered the key, decrypt all those strings, which can be quite helpful. We could use CyberChef for this one as well. I imagine everyone uses CyberChef now. If you're not sure, it's always just easy to try to experiment. So if you weren't sure this was base 64, or maybe they went to the trouble of implementing it here. I don't know why they didn't just use a custom character set, but I guess I haven't tried that myself. I don't know why, I just haven't. Maybe there's more to it than I think. There's our base 64, and then RC4 is another operation. Of course, we need the passphrase. Let's paste that in. There we go. Right, and they're decrypted for us as well. So again, if we're seeing patterns of obfuscated something in a larger binary that we were analyzing, it would be a good candidate to script it out. Whether you write some Python and just tackle the binary straight on, or do it in some IDA Pro Ghidra type of a script. So many different ways to do that. Okay, that's all I had. Questions, comments?
That's really good. I think John had a question about doing
yeah, I see it.
Mm-hmm.
I mean, add to that with RC4 and other simple, fast crypto methods like that. They're very vulnerable to linear algebra approaches. So like someone with a simple, with a GTX 2060 or 3090 or whatever could crank through that entire mathematical space in just a couple seconds.
Yeah, I guess. I don't know. I haven't tried brute forcing a lot of this stuff. Either I have the key or I don't. And if I don't, I tend to move on. I mean, there is some brute forcing that I do, but not too often. So I can't speak to it too much. I would think, yes, just like any, the goal with a lot of this isn't, rock solid anti-analysis. It's just to slow things down long enough for this JavaScript file to be effective for whatever campaign they're using. So if they start distributing and there's a key involved and it takes analysts, 4 or 5 days to catch up with it because their automated tools are missing it, and it takes a while for someone to manually pick up on it, then it's served its purpose. So, a lot of this stuff, it is just another kind of thin layer of obfuscation, anti-analysis, just to slow things down long enough. But certainly they're not expecting it to be super hard. Some of it they are. Emotet did a pretty good job. I haven't dug into it too much to know exactly what crypto they were using, but their post-infection traffic was all over non-TLS sessions, but the payload itself was encrypted, and it was strong enough that it wasn't, you couldn't just brute force it and figure out what the content was. You have to assume certain things. It's probably information about the environment. It might be credentials. It's certainly some of that data is going out, and maybe it doesn't matter. But it was difficult enough that I never tried. I didn't have a reason to, and I never came across anybody else that was either. Although, since you have the binaries, you can dig into them, you can figure out how they're doing their crypto. And I imagine they were doing it in a way that was proper, like any proper application should be. So I don't know if I had an answer for you, but
no, that makes total sense.
Cool. Other questions? Yeah,
How
I mean,
often do you?
This early stage stuff, the further left you are on MITRE ATT&CK, the weaker things tend to be. They cycle through quicker. Maldocs are changed very regularly, very frequently. Small changes to more major overhauls. The intermediary payloads that lead to the actual executable, typically native code executables, they tend to be kind of like this. Not super sophisticated. Not terribly obfuscated, although they can certainly get quite challenging. It's the final Trojan that tends to be the hardest to really dig into.
Mm-hmm.
Yes, Remo, you had a question?
With Maldocs and Excel4, how often have you personally encountered it spawning an additional JavaScript like this?
Excel, boy, I haven't really much lately anyway. A lot of the Excel docs, most of them now are using Excel4 macros, at least the ones I come across. And the ones I come across, predominantly I'm pulling from places like abuse.ch. Dridex is a good example. They're fairly active in the absence of Emotet, and they've picked up their activity a bit in the last few months. They actually use a combination of Excel4 macro content and VBA, kind of standard style VBA. But they don't, I'm forgetting what they do, probably PowerShell. No, they actually just do Windows API stuff direct. So they,
that's what most of what I've seen is the
Windows API. They do like
PowerShell.
URLmon to download a payload and then launch it. I forget exactly. The Word docs, I think, tend to be whoever the groups that are using those. You tend to see a little bit more of the JavaScript, C script, W script being launched there, and then these scripts like this tend to be just straight embedded into those. So you see it enough. Emotet was the most prevalent there for the last few years. They used predominantly PowerShell for the last two of those. So that PowerShell's incredibly common.
Are you seeing this more traditionally from like darknet services like malware as a service providers and things like that, or are you seeing this more from advanced persistent threat groups?
Yeah, this would be more of the former. More what I would say is your commodity malware, your criminals. Not that they're not sophisticated, but you tend to see more of the stuff in bulk. If it's on abuse.ch, it's likely going to be that commodity tier criminal organizations and not so much the nation state. I mean, some of it, I guess, I think, like Dridex and certainly TrickBot's been tied to some nation states, Dridex as well. How much they depend on other criminal groups, though, to handle some of their delivery and their phishing and things like that, I couldn't say for sure. I suspect there's probably some overlap, some collaborative effort, and some of those nation states do pay criminal groups to help deliver their stuff, and then once their stuff's on the host, it's kind of their tools. But even that, the good nation states are going to have much better OPSEC. They're going to have much smaller groups that they're targeting and attacking. I think in general, I mean, look at Orion, the SolarWinds thing. They're going to be far more sneaky as to how they're getting into these environments than groups like this that are just blasting out maldocs and hoping that somebody clicks on the enable content.
So if a student, I'll go ahead.
Okay, I have a quick question. So if you're doing an analysis of a piece of malware, and do you ever run into the problem where like the second stage or the C2 might be dead, so you can't get like that?
Oh yeah, all the time. Yeah. Okay. Yeah, all the time. And some groups are better than others in that they turn on their C2 for very limited durations. But yeah, absolutely. You run into the case where If for whatever reason those initial stages fail to obtain a payload, then you may never get it, and you may never figure out who was responsible. Not that we want to get into the attribution game. That's usually difficult, and I tend to leave that to governments. But it's still helpful to know what the malware family was. I mean, I oftentimes like to know that. I feel like a report is incomplete if I can't at least say that this was attempting to drop, malware X. But yeah, sometimes you run into a dead end. Abuse CH is a great place to look. Virus total can be helpful, although I find it a lot less so as it used to be, because I think abuse CH is just a far more open platform. I like what they're doing there. Passive total, if you haven't used that, passive total is good. You can at least get historic information about domains and IPs that they resolve to, and they've got a free tier that can help you in doing that research. So maybe you have a domain and you had an attack 3 days ago that you're trying to go back and investigate. If it's no longer resolving, passive total might have that information, and at least you can get an IP that it resolved to the day of the attack, and then that IP might lead you to uncover more of what's going on. Alien Vault is another, if you have access to, they've got that online threat exchange. I don't use it too often, but I also don't have a lot of reason to always track these down. So sometimes if I run into a dead end, I just leave it at that. And Twitter, don't forget, there's quite a bit of activity on Twitter. Yeah, Twitter's a good resource. I find stuff on Twitter all the time. I try to post as much as I can to Twitter as well.
So if there's a student that's interested in getting mentoring from you, because I think there's at least one or two in here that probably are, what is the best way to contact you for that?
After you've retweeted my content 15 times, then I'll accept a direct message. No? Okay. Yeah, just an email. I'll put my email. It's easy to find me, but DSU email's fine. Pretty much any way of contacting me that you can come across is fine. I'm fairly active on Twitter, fairly active on LinkedIn. I lurk in a bunch of Slacks and an increasing number of Discords. So question. So Evan, is it you, Evan Bolt? All I know is Evan. So yes, I appreciate.
Oh, sorry, Evan Reed.
Evan Reed. Okay, okay. I only knew one Evan, and I was just taking a chance. Cool. Well, thank you. Yes, I did post a couple of. As I said, as I start to retire material, I figure it doesn't need to just rot on my NAS somewhere. I might as well make use of it. So I've been posting a few things on a GitHub that I maintain, and then one of those got picked up and decided or asked to post on Cyber Defenders. And so I've been adding a couple of challenges there, and I'll probably do that moving forward. With Twitter being a good resource on how to find and learn about malware using it, I don't know any malware that uses Twitter. I take that back. I have actually come across a couple of things that I suspected were using Twitter, but I never dug into it. I probably have the code somewhere. If someone's interested, I could try to dig it up. Using it though as a resource, I would say if you look at who I follow, I think those are some of the primary players in who post a lot. Independent. Some of them are independent threat researchers. Some of them are like groups of people. Cryptolamus, for example, was a group that was very active as sort of this informal collective that was trying to take down Emotet. And while they couldn't do law enforcement action, I think they helped to be a big thorn in the side for that Emotet group. So there's a lot of folks there that I would suggest following. I also use TweetDeck, and I just have a couple of columns which I have filtered on hashtags. I'm particularly interested in open directories. I've been hunting open directories for the last year or so and come across a lot of interesting things, a lot of OPSEC fails by the bad guys. I usually tweet about those. So, as you start following the folks and see what they post, I think there tries to be a kind of some discipline in the hashing, the hashtags that are added to help with that. So you can pick up on a hashtag that you want to follow. And then, if you have TweetDeck open, you can just have as many columns as you want. Yeah, no problem. Follow, like, subscribe. Yeah, absolutely. All right. Well, I've taken up a lot of time.
you're good. It's probably one of the better presentations.
Good. At first, I thought that was maybe a can of Ice House on your desk. I see though, it's just a
No, it's
caffeinated
just
water.
yeah, yeah. I chug these like crazy.
Yeah. If you saw my desk, you'd see a graveyard of caffeinated corpses, formerly caffeinated. Fresca gang. Yeah. Okay, awesome. Well, Micah, I know we can chat about maybe jumping into one of these here in the future again. I certainly don't want to show up and just monopolize the time, but I'm happy to share whatever I can. As I'm sure you're all well aware, there's 700 different paths we could go down. There's plenty of stuff to talk about. So if I know it, I'll tell you. If I don't know it, I'll let you know that as well.
If anybody decides to do something with Josh, you can also present it here at our last few meetings that we'll have this semester.
Oh yeah. So I do have, so one of the students we did decide to start with a blog. So if you're going to do the analysis work, you might as well get a little mileage out of it. Turned out to be nothing too exciting. But still, you got to pick up the little bits of information here and there. So yeah, maybe he could jump on and present 5-10 minutes of all it would take. So I'll coordinate with you and Odin on that and get him lined up as long as he's interested in doing it. He's a West Coaster, so this is actually later is better for him, I suppose, because he's 2 hours behind.
Yeah, and it doesn't have to be like a really deep technical dive. If you just want to do like slides or stuff, that's okay too.
Yeah, I think it would be informal, kind of like what we did here. He could share a few things on a screen or just run through the blog and show you the screenshots or something. Mm-hmm. Yeah.
We always welcome any of our students that want to participate in and share, give presentations on whatever.
Yeah, absolutely. Okay.
Well, thank you.
Yeah, Shall think maybe then I'll drop off. I've got a cold hamburger waiting for me. Okay. I did want to hear more about the Mac malware, but I guess I'll have to catch the YouTube. So
yeah,
I'll do that
if you want.
Mm-hmm.
You're welcome to stay and eat your burger with us if you want.
Oh yeah, well it's also bedtime, and I've got three young children that need to be corralled like a herd of cats into their beds. Mm-hmm. But I will definitely get on. Let me find. You shared me the malware club. Oh, you guys are really elite here. Malware used to be a thing. Malware.com.
Yeah, I've tried. I keep trying to go to their website, but it's dead. They were supposed to have brought it back, but they never did.
No, that's the Cuckoo guys. And they now have Triage. So I would suspect that Cuckoo or Malware, well, it was a .com. I suspect that will never come back. Okay. But there is Triage, and they do have free accounts. And if I actually know Jurian, who is one of the lead people of Cuckoo. So if you ever need anything, if you can't get access to the account, get signed up on Triage or something, let me know. I can usually ping him and he'll add people. I can't remember if they've opened it up to everyone or not. So
I think it was my second year of undergrad, we did like a Cuckoo project. And if you remember Ezra Chona, he joined their Slack channel. And while we were building our Cuckoo instance, he was able to ask him a bunch of questions and stuff. So it was
to Jurian.
Yeah, it was pretty informative.
Yeah, they have their Cuckoo their Slack is unfortunately pretty quiet, but you can definitely get help there. And Cuckoo itself has been pretty quiet. They haven't done anything significant with it in a while, and so I suppose Cape is really the direction to head. But it all depends on what you're after. So yeah, and if I ever make it to campus, I have a stack of Cuckoo stickers. I don't have an example of one laying around, but I'll bring those. Maybe you can share those. Apparently, they're hard to get a hold of.
Oh, sure.
Okay, I'll shut up. I'll follow up. I see maybe I got a couple emails already, so I'll definitely follow up with anyone who sends me an email or messages me in any other format. And then I'm sure I'll join in another future club meeting. And if there's anything else though, in the meantime, don't hesitate to ping me.
Yeah.
If anybody has any like very serious aspirations of becoming a malware analyst, and this would be, you know, a good opportunity to take them up on that. But thank you for coming, Josh.
I try. It all started when I had to teach CSC 432 years ago. Very unorthodox way of getting into it. All right. Thanks, guys. Thanks, everyone.
Thank you, Josh.
Have a good night. I'll talk to you all soon. Grandma, I'll talk to you tomorrow.
See ya.
All right. Bye.
Thank you, Josh.
Yes, you're welcome.
And then I think Micah has his presentation now.
Yeah. Yes, we can switch over to the second half. And hopefully I can wrap this up in under an hour. But the second topic was going to be the M1 Mac malware. So we'll be going over just a couple of things for that. Yeah, my slides real quick. Can you guys see my slides?
Yeah.
We can.
Yeah, so macOS malware. Just to start off, a couple of articles you might have seen lately, just over the past week. Namely, there's been one malware variant in particular. The Silver Sparrow wings, I guess is. Yeah, no, Silver Sparrow, and it's it's a type of macOS malware that for a while has been on the Intel architecture, but there's two parts about it that we'll get into why it's been so popular. Mainly, it's just because it's one of the first two that's been natively compiled for the M1 architecture, and then also it was deployed using JavaScript within the Apple package installer. So that'll be a pretty interesting dive. And if you want, there's an article here from Dark Reading that just kind of goes over why macOS malware isn't as popular and why you don't see as sophisticated types of malware compared to what you might see for Linux or Windows. And I can give you a quick reason for that. And that's just because for Mac malware, it's more targeted at the user. Simply like, with Office macros with like VBA scripts or drive-by downloads, those sort of things. Because for some reason, the people using Macs are more likely to just open it and run it. And, that's how it's being deployed. And then this last one here, I think this one was pretty popular topic when it first came out, and this is different from macOS malware. This is iOS, but there was a service being used to target journalists using the iMessage zero-click exploit. If any of you want to look at these, you can open the slides on the drive. I'll put it in the chat again. Type that. And then this drive is where we'll also have some of the malware binaries that you can download, and we'll go over that in a bit. And the slides are in under the slides folder, labeled macOS malware. So then, just to quickly, go over that again. Some of the typical infection vectors that you're going to see for malware, mainly because it's targeted at the user. You're going to see things like fake updates, fake applications, Trojanized applications where like they might download something, like you might see like a crypto broker where you can use it to manage different exchanges or your wallets. But while you may actually be downloading a real application, it's also sideloading a Trojan backdoor as well. And then you also have infected pirated applications. So you're downloading things off of like Pirate Bay and you're sideloading things that way. And there's also Office macros, and that's just typical like Word documents with the VBA scripts.
Wait, you mean pirated applications aren't safe to use? What?
Yeah, real surprise there. Then lack of sophistication. So why fix what ain't broken? It's because again they're targeting users. And you can see some brief little snippets over here that I grabbed. So you have an instance where there's like a fake Flash player that's telling you, oh, it's out of date. You need to update it. You've probably all seen this before. So it just asks you to download it, and then it runs it from there. And there's also this one here with WhatsApp where you go to download what you think is the actual application, but there's a hidden iframe that actually causes you to download a fairly different one. So one of the ways that they've tried to combat this is, and I think one of my slides is missing, so I'm just going to skip to it, is the notarization certificate system from Apple. And they introduced this in the last update. I think it was macOS Catalina, which is version 11. I might be wrong. And what that does is it's kind of similar to just Microsoft certificate system. It's a way that they can identify applications made by developers. But their main reason for doing it here is so that if they detect that a developer is doing something foul or their certificate's being abused, in this case to develop malware, they can revoke that certificate and then prevent that from being installed or running by default on most people's systems. So and there's also been some conflict with that because most people don't like the idea of Apple devices and how they're so locked down and they prevent developers from doing what they want or even the users. So and then there are other issues of course with this system, and that's if the only way it really helps is after the fact. So if somebody creates a new piece of malware and they go out and in fact let's say it's Silver Sparrow 30,000 systems, the notarization process is only really helpful after the fact. It's still not really getting ahead of the curve, preventing it altogether. It's just another after the fact thing. So we'll just jump back a few. So now just getting into the actual differences with the M1 Mac malware. I've kind of just condensed this article from Objective-C by Patrick Wardle. I guess he's kind of considered a subject expert for this. And I mean, that's really true if you look at a lot of the open source tools that they provide, like this one that's shown here, Lulu. And then they also have some more defensive ones that actually monitor the different behaviors of applications, which is something you'd like to see done by Apple natively on macOS, where they're monitoring, application behavior to prevent things like persistence and whatnot. But there'll also be some links later on, because if you'd like to learn more about the static analysis and just general process for looking at Mac malware, he has a textbook called The Art of Mac Malware that you can go through and you can learn a lot more from there. And the nice thing about that book he provides is you can actually go through all of his resources and you can see that stuff there. Sorry, just noticed the chat was there. Yeah, so in particular, this article came out like on February 14th, and then everything with Silver Sparrow followed like 4 days later on February 18th. So it's kind of just interesting looking at that and seeing just how close the timeline was. But the article by Patrick Wardle, coming out first, reason why it's just sort of important to go over is because he just shows that the malware that's being used natively on M1 systems, which is the new CPU, or the well, they call it a system on chip, but the Apple SoC, it's ARM based. It's not the typical processor and architecture that they've been using from Intel. And when you look at that, I mean, there are two different architectures. So that means when you compile your software, you have to recompile it to run on that architecture as well. That's why you have issues like you have the Windows for ARM, but all of the native Windows PE32 files won't run natively on an ARM64 Windows device. And where that separates, Apple with Windows is that Apple has a Rosetta translation. So what that allows is calls that would be made for a x86-64 architecture system are translated into ones used by the Apple M1 ARM64 architecture. And there's another aspect of this that's not necessarily addressed widely, and that's so with the Rosetta translation, what that allows is things that weren't natively built for the ARM64 processor to actually be run on that system. So it's kind of like a emulation, but it actually allows it to run on the chip, which is the big difference. And what that process looks like is you take the x86-64 executable, it will translate it, instruction for instruction into the ARM64 binary, and then it will run that directly on the chip. And you might wonder, well, why do you actually need to recompile it for the M1 chip, in ARM64? And the big reason is, one, I mean, you get like an increase of speed just because you don't have to wait for that translation period. And then also, there's less bugs because you're just natively compiling it instead of having to translate it. So whenever you run into stuff like that, of course, there's going to be issues. So one of the first steps you can actually do to see if you're dealing with a binary that's been recompiled for M1 Macs is what you'll see is that it's not just going to be an ARM64 binary. What you're seeing is that they create what's called a universal binary or a fat binary. That's where it's built for multiple architectures. You'll see a tidbit at the bottom when you're looking at executable. You'll see this because you'll see there's a multi-arch tag. And an easy way to do that is just by using the file command. So you can just do file, the binary, and then you'll see it's macOS universal binary with two architectures. So you have the Intel x86 64-bit executable, and then you have the ARM64 macOS. So what this allows is that when a Mac device decides to run this piece of software, it will run the, automatically it'll choose the architecture that best fits that sample or that system, sorry. So if you want to find more samples to look at, one thing that he commented on was that you can just go straight to, sorry.
Yay, cat.
Yeah. Yeah, she doesn't like being ignored for multiple hours. Oops. Yeah, so what you can do to find these samples is you can use this search query right here. So it's type macOS for macOS, tag ARM, tag 64 bits, and then tag multi-arch. And then I guess he uses this well tag signed because it needs to be notarized. And then the positives, just so it's been detected by at least a couple of ADs. And then another issue when you're doing that threat searching is that there's going to be both the iOS binaries because they've been using this ARM architecture for all of their mobile devices, like with the Apple TV, iPhones, iPads. They already use ARM, so and he did comment there's no real way to that he could think of at the moment, and I can't really think of it either, how to prevent iOS samples from showing up. So you just kind of have to deal with it and dig through all of it. Yeah, so that's one way you can find them. Like Josh suggested, there's a bunch of other sources you can use. Besides VirusTotal, you could also do hybrid analysis. There's Joe Sandbox, Alien Vault, a whole bunch of them. And this right here is a particular one that they went over in their article, and that was the Go Search 22. And the interesting thing about it was that it was one of the first samples he could find that was natively built. So, as a universal fat binary for both the M1 and the Intel chips. And if I can see in here, I believe it's an older binary. Like you can find a bunch of these going back to like November or December. So I'm not sure how much the statement Silver Sparrow being, the second piece of malware to be natively built for M1 actually, holds its weight, with that statement. But if you want to look at more of these, you can just go straight to VirusTotal. You can use that query, and you'll find a whole bunch that you can look at. And then when you do download it, yes, that's the notarization. When you do download it, you can just do the file command, and you'll find that there's the two binaries. To unpack it, I don't know how to split it. I think he covered it later, but sorry, let me see if I can. Yeah, you have to use the lipo command, which is a macOS utility. So if you want to run it on Ubuntu, you'll have to find the source and then compile it for your system. But if you, and the real issue that I haven't gotten to yet, but people have with the ARM64 binaries being natively compiled versus just the Intel ones before is the whole malware virus detection. So, the way it works is if you're using like statically defined signatures to detect these things, when you recompile it, it's in a different architecture. So you might not be able to look for the same exact byte patterns or even like the same magic fields. So what that looks like then, if you were to submit the ARM binary and then the x64, oops, is so like right here, you have the ARM64 on top and Intel on the bottom. Obviously, this isn't going to match up with my statement because I'm looking at this 5 days after it was submitted. But at the time when he wrote the article and when a lot of people were, initially talking about this, the AV engines hadn't caught up with it, and there's about a 15% less detections of the ARM64 versus the x86. Between that's antiviral or antivirus detection software or services, which is a pretty big issue when you think about it, and it can actually get even worse when you look at detections for, and this is all the same. This is the same binary. It's the exact same thing. It's the same code. It's just been compiled through a different architecture. But you'll see the same issues with things that have been cross-compiled, so across different compilers And then also with different optimizations, you'll see these same issues with detection. And it has to do with the types of signatures they're using to detect them. And you also see like a mismatch between labels for those binaries. So it might classify one thing as like a Trojan, and then you'll see like somewhere else it says like win, like backdoor or adware. So it'll even mess with their ability to accurately like classify or categorize that new malware. Um, so then the actual piece of malware that we're going to take a look at, that is kind of the same thing and has been a bit of a buzz lately as well, is a report from Red Canary about the Silver Sparrow that affected about 30,000 devices across 153 countries, and this was as of February 17th. So it's probably gone up by a few since then, unless, and I do believe Apple pulled the certificate for it, so technically people shouldn't be running it and it shouldn't be infecting more. But mm, as far as people go, I mean, you can usually expect the worst to happen when it comes to malware. So yeah, the two main versions that they came across for this was there's malware version 1 update.package, and then same thing, malware version 2 update.package. And the difference between the two is that the version 1 is built only for Intel x86, and then the version 2 is a universal fat binary that has the native uh, compilation for the ARM64. And we mentioned this at the beginning as well, but what really made this one stick out, for a couple of reasons, was just the sheer number that got infected, and the fact that it used JavaScript code to deploy the persistence shell scripts. And then three, there's no payload. So all it does is it sets up persistence, command and control, with nothing else. Like if you actually open up the binary, and this is in a bunch of analysis reports, it's literally just a hello world.exe. Um, and we should get a chance to look at that in detail if I can open it up in Radar. I was looking at a bunch of resources, and if you're going to do macOS malware analysis, it's actually best to do it on a macOS machine just because it has all the tools like OTool to actually look at it.
Hey, Micah, can you explain why it's maybe worrisome that there is no payload?
Yeah, so and a lot of people talk about this, and the thing that they noted was that so they kind of just use Hello World as a placeholder. So even though it didn't, play any additional role in the actual execution, the fact that just, it performs as a placeholder, it shows that if they wanted, they could do something outside of what you see with the command and control they have, and they could push it through and then try to execute it in place of the hello world. Or it could also just be that this is more like a proof of concept, and that if they really wanted, they could have done something much worse. They just didn't for some reason. Like if they wanted, they could have replaced the hello world with a backdoor or something nastier. And you'll actually see that if you go in VirusTotal and you look for macOS backdoors or Trojans or worms or whatever, it does exist. macOS isn't inherently safer than Linux or Windows. It's just as bad. So had they actually included anything else instead of this hello world binary, you know, the 30,000 infections could have been a little nastier. So then I think what we'll do now is I'll actually jump into some of the technical stuff. And because this virus is actually virus malware, you know, it's pretty simple, that it should be pretty quick, easy for us to take a look at. So can you see my VM now?
We can see it, but it's too tiny to see anything inside it. So it's like all blur.
Oh, yeah. So sorry, I just saw your message, James. Yeah, it would be pretty accurate. Just call it a proof of concept at this point. You know, because a lot of this, especially this report from Red Canary, is fairly recent. You know, you might hear more about it in, you know, like a week or two, but a lot of times if the C2 gets killed, then, you know, there's not really much more to it to look at. But again, you could probably just consider this as a proof of concept for now. And if you're really curious, I'm not really going to go over the timeline of this piece of malware, but in the slides, I've included all of the links. Sorry, I'll fix the resolution real quick. The iLab's been pretty slow for me today. Yeah, you can open all these links and you can kind of just look at whatever might be more interesting, or you can just ask me in the chat and I'll look real quick, because I have all the reports and everything. So if I miss something that you're more curious about, I can get it.
Looks a little bit better now. The resolution is improved somehow. I think you maximize your screen. So there we go.
Yeah, it should be better. We'll just back up a little further.
Did you want people to try and follow along or just watch you, like on their own machines?
Yeah, they can follow along. Sorry, I was getting a little ahead of myself. Yeah, so I'll put the link in the chat. Yeah, yeah, it's a little slow sometimes. Usually I have a different way of connecting to it, like when I'm personally doing things in the iLab, but Grandma pointed this out a couple times, but it's better for everyone else when I present if I just use the web terminal, especially when I bump the resolution on it. Yeah, so if you go into the drive, I'll type the link again, just so you guys don't have to scroll. But it's on the drive.malware.club, and you can download the zip, you know, in your VMs. It's called M1-malware.7 zip. I'll give you all a few minutes to do that.
If people need to authenticate, you can always just type, what is it, captive.apple.com, and then it should prompt you for your IA lab credentials.
Yep. Oh yeah, and I'll type the password too. It's the same as the Zoom, so it should download. Malware Club sets MALWRCLUB Malware Club. And I already unpacked everything for you guys, so just to save you time, it's a little messy because I didn't really clean it up from unpacking all the zips. So everything's in there. The complete file structure. There are some parts that we won't be able to look at ourselves just because, you know, it gets some of the second stage scripts directly from a C2. And the only way I'd be able to get those is if I ran this, because nobody shared the, you know, these later stage artifacts like the P lists. But we should still be able to look at actual, you know, first stage of it, which should be plenty of talking. So is everybody got their VMs going, or should I wait a little longer?
I'm good. Does anybody else need more time?
Okay, that's fine.
Just a sec.
Take as long as you need.
So you're going to be using Redori?
Yeah, I mean,
or not?
I was going to, but oops, typing in the wrong box. It still doesn't really look that good enough to present. There's a tool that a lot of people recommended for doing the stack analysis, and that's, I'll type it in the chat as well. I think it was O-Tool, but that's a macOS tool, so.
Is that installed?
No, to do that, it's not on any of the VMs, because I guess Fire, I didn't think a lot of people would be doing Mongo binary analysis, so I can kind of show you what it looks like. This isn't really going to be what we're talking about for today, but yeah. So I haven't actually done a whole lot of Mako stack analysis before, so I'm still trying to figure this out for myself. And you can't open this in IDA. Maybe if you have IDA Pro. I use the IDA free version, or the IDA Pro trial, and it doesn't have support yet for the M1, you know, Mac architecture.
The people in my class probably can open it with IDA Educational. I suspect it would provide that. I'm not sure though.
Okay. Yeah, if you guys wanted to try that, you could. I mean, you have all the samples, so. See if I remember how to navigate around this. Yes, this is all the functions. So it starts here in the entry, and then it goes to NS application main. But again, I mean, there's not really anything really interesting to look at here because it's just hello world. But you can kind of see how this looks maybe a little different from your normal DE file, because there's what people use for writing or developing programs on, you know, for Mac and Apple devices is the Swift language, and you can see a lot of those function calls here, like with Swift UI, and that's because it just draws a box. Yeah, it literally just draws a box that says you did it. I tried digging for all. I didn't find the reference for the string. I'd assume it would be here under this object message send or send super. but it's pretty messy. So for doing a static analysis, this isn't. If you guys want to do malware analysis for Mako binaries, we can really do that in the next meeting because I'll have to get a bunch of tools ready to install on your VMs, so you don't spend like 2 hours compiling everything. So I might push out a new VM image or template with everything. It'll take me a while to gather everything. I might maybe I'll even send out a Mac template, but I'm not sure that's allowed. Yeah, let me see if the really interesting thing that you can look at again though is just doing the file for the binary, and here it's just the Mako 64 bit for the Intel. That's because this is the version 1. If I didn't really touch on that, but you can see the hash because I kind of jumped ahead. But this is the hash. If you look at the slides, that's for the version 1. So, when you see here, it makes sense that this is the Intel executable. If we were to back out quite a ways, oops. Oh shoot. I closed the. Yeah, sometimes I forget you can't do Control W for the terminal when you're using the web console.
Oh yeah, I hate that.
So I have a bad habit of actually closing the window. Sorry, I got it back. There you go. Yeah, so I'm assuming everyone has it downloaded by now?
Speak now or forever hold your peace.
Yeah, because okay, cool. Sorry. Just to save time, we'll just kind of jump into it. Yeah, and there's that. I know there's a way you can get around it, but I'm not sure, like people like Eric or Kyle would be happy with it.
You can always ping Eric and see what he says. Let him make the call.
Yeah, because I mean, it'd be kind of interesting for us to go over if we actually had like VMs to do it, but it would take a lot, and I think you actually have to have like physical hardware to do it with. I'm not sure how easy you can do it in like something like VMware. Because I know if you use something like, I think it's called Clover, you can put, Mac OS on like a Windows PC. Yeah, I haven't done it myself. Yeah, so we'll just kind of go back to the beginning because I jumped a little too far ahead. So if you go back, and for you guys, this is probably in your downloads folder. But for me, I put it on my desktop. So you'll have the two binaries when you unpack it. There should be a one DEC, and then a C7DD. The one DE is again, it's Intel, and then the C7 should be the version 2 with that binary. And the big part about this that was really interesting was the way that the malware was being deployed, and I said that it was with JavaScript. So to look at that, we'll have to unpack it. You can actually, I had a hard time doing it from the command line because for the command line tools, for some reason, you have to like change the extension for it to detect that you're actually using that file, it got mad at me for just trying to do it, and it said that it wasn't a file. But once you unpack it, even though for you guys it should be just the file with no extension, if you just right click it and you mouse over 7-zip, you can do extract files, and it should open up into a file structure with another binary inside for both that you can open. Like here, I renamed mine PKG. And all this is unpacked, so you don't have to do it again, but I'm just explaining it. You can extract that as well. And then it should go further down, and you'll have the distribution and tasker.pkg. And then you'll go down again, and there will be a bomb, package info, and a payload. What we can do here, and this will kind of help explain the file structure a little better. So I'll go into the C7 just because, I mean, really all we care about is the version 2 for the M1 Mac. CD into the C7 again. We're going to come back to the distribution, but we'll just do the file command, and the distribution is an XML document. And that's mainly used just because it's sort of like it's a definition file. So it contains a lot of the installation specific information for the Mac when it, unpackages it and it wants to know what, is being installed. We're just going to go another folder down into the tasker. And here you have the bomb, package info, and the payload. I already unpacked it, so there's another folder, but we'll just do file again. So there's the bomb, which is a macOS X bill of materials file. You have another package info file in XML format. And then there's the payload, which is another gzip. So for that payload, you could go back to your folder and then use 7-zip. You can just right click and then go here and extract it. And that'll unpack it again. Excuse me. If for whatever reason you don't have 7-zip, which should already be installed, you can just go like pkg extract online, and you'll get this one right here, extract.me, and you can upload it. Like I'll show you. Payload, and then it gives you this, and you could save it and you could do it that way, or if you're at the first part, you could just go like here with the initial PKG, and then here's the file structure again. So, I mean, that's how you dig through it without having a macOS system to use XR to open it, without actually using the macOS installer. So before we get into the payload section, which has all the actual like package installer for if you were to install a binary, like the Hello World program that it installs as a placeholder. The actual like juicy part of the analysis is in the distribution file, which they put a bunch of JavaScript in. So for that, we'll use, you just right click on it and open it with Sublime. So pretty kind of funny. So this is kind of like my first foray, into looking at Mac malware. So I'm not sure how commonplace this is, but so within the XML, distribution file, they have an installer GUI script, and then they have a JavaScript tag here, and this function for installation check here is the main part that a lot of people were talking about. And the reason for that, and this is all a lot easier to look at than what we covered earlier with Josh's segment, and so we're pretty lucky that it's not obfuscated. But right away you can see that they're using the installation check function, and then right under that you have the system.run. So it's using bin bash -c, and that's going to execute the command that's been provided. And you can read more about that under the Apple documentation for system.run. But that don't really need to do that right now. So then to really figure out what that's going, you can see here, so it uses bash up here to then do system.run to execute each of these commands you see. So that's really all that does. That's how it gets around the file system and establishes the what we'd seen earlier about the persistence command control and those parts. So where it gets interesting is it uses the lines a little further down for append line. So this chunk here. So what it's doing is it's using these commands through bash to write files directly to the disk. So it does each of it, line by line using JavaScript commands. It's a bit simple, and if somebody really wanted, they could probably use like YAR rules to define this. But I mean, the real point of this is just the novelty of the fact that it's using JavaScript to write directly to the list for the key lists that you can see here. See if I can. So you can see here it uses bluetail, and it's writing to these temporary version.json and version.plist through a curl. So it's using a curl directly to like a C2. It's pulling it down. It's putting it in a plist. So you're probably wondering, well, what's a plist? Plist, it's I guess it's a sort of process list buddy. It's a process created by the launch agent, and what it does is it allows it to use launchd, which is how macOS will periodically or automatically execute tasks, like Windows task scheduler. But the thing is here that the malicious actor can write these p-lists, somewhere else, from the C2, and then they can use this functionality to, push new process executions directly into the scheduler for the macOS device. And then it will update it, directly with the updater monitor path, with update time. You can see current version, things like to date run. And you can see then it clears up a lot of what it does in the different directories. So, and I guess they say the main issue with this is that while it might be easy to detect this, like if you download it and you're doing like file inspection when you're going to install it, the issue is that with the way that they're establishing persistence. So, and they say as a result, detecting a persistence mechanism in the form of malicious launch agent can be extremely difficult. using EDR. That's endpoint detection response. So if you're familiar, that could be a tool like Malwarebytes Scanner or Carbon Black, Splunk, a lot of those things where you install like a sensor on the device and then it tries to monitor those behaviors. By nesting these file or binary execution tasks within the LaunchD task scheduler, it can be harder because supposedly they have to analyze surrounding activity around that decision for the installer itself. So it's like having a bunch of noise surrounding what they're doing, and it's just harder to dig through it. So further down, there should be eList Buddy, so like here, where it's curling it, and then it's getting download URL for another version.plist. So it downloads a bunch of these, and then it pushes them in and out. So, and they didn't comment on it here, but what they could be doing, because the C2 is dead, they can change whatever plist is downloaded and what's being executed from that task scheduler, because it's not really controlled on the client. It's being pushed through the C2 and then down. And then sort of the later part of this is that the final callback that they have, and I didn't comment on it, but the C2 that they were using was a Amazon AWS instance that they they would curl directly from it, and that's where they would get all these plists and JSONs for establishing those task rules. But after that, this later half down here is so they're creating an agent, and then they have their final callback using the SQL Lite commands here to the library preferences, quarantine events. And when it retrieves the system UID for reporting, the second it finds more interesting information, the URL will be used to download the original package file. So it's kind of confusing everything it's doing, because you can see, that they're pulling everything from the C2, but then without those plist files, and then the final callback to the server, where it's going to download a secondary PKG, or it could be anything else. And the PKG is just a method of suitable installation for the system. You could really be seeing this used for just about anything else. They didn't get to deploying this and pulling down any other packages, but the fact that they even had that system in place and that they could successfully distribute further methods of persistence to systems is what a lot of people are curious about. And at the moment, other than some tools like what's provided by Objective-C, because they actually have some tools called Knock Knock. I don't know if anyone's familiar with it, but it's supposed to monitor for things like that are being done here with the plist for persistence mechanisms, specifically, and they go on to talk about using monitoring of launch items with the plist, which is what this is doing in the distribution. But Apple doesn't do this natively, and I'm not sure if a lot of AVs do it as well. So yeah, that's really the big part of this. And this isn't even specific to, oops, I'm lagging too much to do that. This isn't even really specific to the M1 Mac Malware itself. I think if we look at the distribution file for The other version 1, it should be about the same. Yeah, so you can see here, it's the exact same. Minus, well, minus some naming, like updater.package versus Tasker, but the goal is the same. They go to the same C2 and they pull down the same thing. So really, like the main takeaway from all of this is that a lot of people thought that maybe the M1 would be more resilient, or compared to the Intel systems, or Apple might have that added layer of obscurity, security through obscurity, to prevent malware authors. But in the end, all they really had to do was recompile, and now they have malware that can be used against both system architectures. Not to mention the whole Rosetta translation that they have. So there's backwards compatibility for any previous Mac malware for Intel systems that can still be run on M1 systems. Maybe with some bugs, but I mean it's still there. Yes, I guess I should ask, does anybody have any questions about this? I have a lot at once.
Not a question, but a comment. I noticed that the other one also has its own distribution thing that's similar, but a little bit different.
Mm-hmm. Yeah. So what was the thing that you noticed?
I didn't really notice anything. Just
sure.
Just slightly different. One is like 155 lines. The other is like 125. So
yeah,
there's.
That's a good point.
So as a question here.
Yeah.
This was not distributed, obviously not distributed. Was this distributed through the App Store?
Oh,
or
no.
Is this just okay?
Yeah. So, oops, wrong button. Yeah. So I guess that's, and you may have read about this, but that's why in the earlier slides we briefly talked about the notarization. So Apple's thought process for preventing some of the malware being deployed on their systems is that they want all developers, not just those in the Mac store, but any third-party ones who distribute their software outside of the store. They want it to go through their notarization process where they submit their compiled binaries to their notarization, and then sort of like an ID tag is created from it, so that in the event that their tag is being abused or whatever, or their software turns out to be malicious or being abused in some way, they can revoke that notarization, and then those programs won't be running without further permission on systems anymore.
Much like Microsoft does.
Yeah, I mean it's kind of like a bandage for a really big boo-boo, but it doesn't really stop anything other than maybe the average user, because now they see another prompt and they go, oh no, I guess maybe I shouldn't run this.
Much like it's like Microsoft Smart Screen.
Yeah. So I mean and they're not really doing any active screening for software once it's being installed on a system. That's why if you want, you have to employ other software like Knock Knock to look for those persistence mechanisms, like the launch D agent. Otherwise, I mean, if you install something, even if it's third party outside of the store, you don't really know if something's being side loaded.
Mm-hmm.
And another tidbit that I learned through some of the research I was doing for this, Mac devices, they have a firewall, but it's only for incoming connections. Whereas if you have something like Windows, it does inbound and outbound filtering. And on Mac, there's no outbound. So if you want to be monitoring for any software that you have or software you don't know you have, and you want to make sure that nothing's making unauthorized outbound connections to potential C2s, you have to install other software to monitor for those actions.
Mm-hmm.
So, and if this topic is really interesting to people, and you'd like to learn more about the actual sort of static analysis process of Mac malware, I do have some resources I've been reading over, and we could discuss like the structure and differences between like Mach-O binaries versus PE32, which I'm sure is what most people are more familiar with, especially like the whole PE file structure, specifically.
I would be interested in that. Or what about other students? Are they interested?
Interesting to see the breakdown of the Mac binary structure and how it and the different types, because there's different types of binaries that Darwin uses.
Yeah. So, I mean, we're already at just about 2 hours today, so I can prepare that for our next club meeting. Let me look at my calendar because I'm really bad with days. On the 9th. And then there's a bunch of samples out there that are more interesting than this one that we could do after we've gone over the file structure. And I also, let me switch my screen back to my slides. Oh, yeah, so I guess I have these questions. And, maybe this is something you guys would like to present about, at a later date, either after our next meeting or maybe for our next meeting. Oh, sorry. 9th would be over spring break. Oh, yeah, you are probably right.
People want to meet over spring break. Do they care or not care? Should we take a vote?
What's the spring break you speak of?
I think it starts on like the 6th, or no, I guess technically starts Monday the 8th, and so Monday the 8th through the 13th is Saturday, so
yeah, that's my bad. I didn't think about that when I put the schedule together. Yeah, I mean, we don't have to meet on spring break if you guys would prefer that for just not doing anything school related. But I understand that. And we can push it out the week after.
well, Neil has a ski trip. We could just do it the week after. I don't know, or the week before.
Yeah, you guys don't have to feel.
Probably not the week before because you got to get stuff ready.
Yeah. I also have a bunch of personal stuff happening right now, so it. I have a 4-hour interview to prepare for. So it's fun.
Why don't you decide, Micah?
Okay.
Spring break or not? Neil can't come, so to him it might be good to do it, but up to you.
Okay. Yeah, I mean, it seems like most people would be able to. I mean, minus Neil, but we record everything, so.
Yeah.
Yeah, I guess I'll figure that out tonight or maybe tomorrow, and I'll either email or I'll put the decision in Slack.
Odin's going to be busy. You going back home, Odin?
Yeah, actually, I think I'm going back home for the entire semester.
Oh, really? Wow.
But I'll be like finishing up my research project and everything over spring break.
Okay.
Nice.
Maybe we
Yeah,
should just wait till the week after spring break, because Alden
okay.
and Neil are going to be busy.
Yeah, that's fine. That works better for me. It gives me more time to get acquainted and act like an expert. um,
You did quite well, actually. I work with a lot of engineers at my company, and you presented quite well and did a good job.
oh, thank you.
And that's one of the reasons why we like to have these types of things, so students can have the chance to present. And
Yeah, I mean, from my knowledge, just from having done the undergrad and uh, grad, and now actually trying to get a job and stuff, I know as students we don't really get a whole lot of opportunities to deep dive into these things besides just the homework we're given. So my hope is that this kind of gives everybody an opportunity to go a little bit further and maybe inspire you to do your own things as well.
Yeah, I'm actually kind of shocked at how this actually kicks off and runs, does this, adds in all these appends to basically do. It looks like common vulnerabilities that are being utilized here, exploited
Yeah,
to inject all of this. And you would think that Apple would have done a better job about protecting this kind of environment, regardless of whether it's ARM or x86.
and yeah, that's it's a good thing you brought it up because I mean that is kind of like the whole uh, synopsis for this presentation is that it's just kind of shocking that something so simple is actively being used and that there's no monitoring being done. So it kind of defeats the whole statement that Apple's more secure than Windows. I mean, it's not necessarily to say that Apple's bad. It's just there's no monitoring being done for those things.
Oh, it sounds like that's going to be it's going to get updated here with the next major release.
Mm-hmm. And
Um,
that is something they're trying to address with Big Sur, but with the whole because they're going a step further with the notarization process, and they're making it mandatory that people submit it. And they're not outright blocking binaries from being ran. Again, it's just um, when you do it now, you actually have to say, "Are you sure you want to run this?" It's from the internet, not the Mac store.
mm-hmm.
Um, yeah, and then I mean, I had two questions just to make this a little more interactive for to get everybody to think about what we'd gone over. And it's just, are there any ways you would try to improve the detection of malware, across architectures? That's so it's the same code, but it's just been compiled differently. Would you try to keep using like YAR signatures, or would you attempt things like bin diffing?
I mean,
Mhm.
this is JavaScript. This is just in time. This is just in time. I mean, it's packaged. Don't get me wrong, but it's just in time
Mhm.
compiled. Um, Stuff. I mean, this is something that, uh, you know, hate to break it to you, but a Windows Defender would catch this.
Oh yeah, yeah, no, it
Um,
it would.
so I mean, it's. This comes to me across as like this would be caught by heuristics.
Very basic heuristics.
Not even getting caught, not even looking at signature analysis. I mean, this should
Mhm.
have been caught easily. This was a big escape.
Um, yeah, and I mean, so I did bring this up. So, and you mentioned just doing basic heuristics, but there's a software you can install from Objective C. Let's see if we should have the link in here somewhere. I'll go. Can you guys still see my screen?
It's a bit small, but
Okay. Yeah.
Maybe
Sorry.
you increase the font.
Is that better?
Yeah.
Yeah. So I'd mentioned the guy Patrick Wardle, and he's kind of like the aficionado when it comes to Mac malware, and he has a bunch of these tools that he provides that actually lock it down a lot. But the one in particular that would probably prevent something like this, and he commented on this, is Knock Knock. So what it does is it monitors for any use of like persistent mechanisms to either further establish more connections with C2 or to nestle itself within the operating system. You can learn more. So what it does is it'll monitor for things like proxies, login items, hooking, periodic scripts, or more namely what we just went over. That'd be like startup scripts with the launchd agent. So there is some stuff out here, but like you said, it's not being done natively by Apple on their systems. So this is something that's worth looking at. And then we can kind of just skip my other question. Super basic, and you kind of already touched on it, but some malware resources. These are probably what I'm going to be going over to prepare for our next meeting. But if you guys want to look at it too, you're more than welcome. Just so that maybe you have a better idea of what I'm talking about when I present it. Just because I know this stuff can get really confusing if like you're not already familiar with it ahead of time.
And the links, it should be in the Google Drive. You can find the slides there.
Yeah, it's just under the slides folder. macOS malware. It's the last slide. But these are some really good materials. If you go through this Objective-C, I'll click it actually, and I'll show you. He has a whole bunch of chapters on doing malware analysis for Mach-O binaries, and he goes through static and then dynamic. Some of the things you can do. So it's interesting.
Looks like it could almost be its own class.
Yeah, it probably could. Maybe there's an opportunity for you.
We did have one student that suggested a reverse engineering minor. He liked my reverse engineering course so much that he was asking for that. And that has been taken under advisement and discussed as a possibility for the future, but probably not for any time in the immediate near future.
Mm-hmm. The field's so vast that like you could spend a whole semester just covering multiple semesters just covering it.
Mm-hmm. And it's a completely different world compared to Windows. Windows, because and the GUI layer on top of Darwin just makes it even more confusing, because you still got stuff back from like the days of system still floating around in the OS X kernel, in the OS X environment.
Yeah, there's a lot of stuff they just haven't addressed for whatever strange reason. But that's all I had for today. I don't know if Bramwell or Odin, do you guys have anything you wanted to talk about?
Odin, do you have anything?
Nope, nothing on this end.
Okay.
I don't really have anything at this point.
Okay. I will amend the calendar. Probably not over spring break, so it'll be the 16th. Just so if a bunch of people are going to be missing, and I don't want to interrupt anybody's spring break. So, yeah, I guess that's all I have for today. And
I guess one other thing maybe is if people are wanting to present things in the future or having ideas, think about it, get in touch with Odin, get in touch with Micah, and it doesn't have to be a full presentation. It can be like 5-10 minutes, whatever you feel like, or you could coordinate with them for an activity.
Mhm. Yeah, you're welcome, John. So I will just end the recording here.
I have one